Alright, now that you have the idea of how you would actually make a pi calculator in your head, let's actually work on this in Python itself. So let's get started. Let's import numpy as np. And we go down here and type size is equal to, and let's set this to 100 to start out with. So this is going to be so we're going to basically, if you haven't watched the last video, we're going to be choosing a random number between 1 and -1. We're going to be doing that twice to find a random pair of coordinates on a grid. And then we're going to see if the distance, if those coordinates have distance from 0, 0 less than or equal to 1. So that's basically going to find, is the point inside a circle with radius of 1, and then that will equal pi if we divide that by our size, however many random numbers we have, and then 4, multiply that by 4 for each of our quadrants. So that's how that works. So now let's go down here and create a loop. So for n in n 100 times np dot arange size. So basically this is creating a loop where it checks for each value in size, it runs this loop. And we have this 100, this will basically, later on, it will smoothen out our graph, smoothen out our answer so that it's more accurate. And I did a test run back here, this is way less accurate, and then up here we have one with this 100, and this is a lot more accurate than these two graphs without the 100. So that's why we have that there. So now if we go down, we type x start is equal to np dot random dot uniform, and then parentheses -1 dot comma 1.000000 1 comma n. So what this is doing is this is creating a random number that with this uniform means that it's a random number, but each number between -1 and 1 has an equal chance of being chosen. And we have this 1 here because Python basically doesn't use this number. It uses the number 1 less than, like 0.00001 less than it. So that's why we have this there. And then n, it does that n number of times, so whatever value of size we're on. So let's say we're going through the 50th time and it's going to be 50. We're going to do this 50 times. So that's how we get our graph to make it more and more consistent as we keep going, more closer to this pi right here. And then we copy this, paste it, and then change this to y dart. Alright, now we go down here and type dist is equal to np dot sqrt of x dart times x dart plus y dart times y dart. So what this is doing is this is creating a variable dist or distance, and which is equal to the x dart, which is this random number, times the x dart, y dart, plus the y dart times the y dart, square root of that. So that's the Pythagorean theorem. We're basically using the Pythagorean theorem to figure out what the distance from 0, 0 is with this code here, with x dart, our x dart, and our y dart. Finding if this pair of coordinates is less than or equal, is what distance from 0 it is. And then later on we'll find if that's less than or equal to 1. So let's go on. Let's type success is. See if I spelled that right. I did not. One less S there. S there, and get rid of that. I cannot spell today. And then have that equal to 0. So that's equal to. So that's going to be how many successes that we've had, how many times that this has been less than or equal to 1. So now we're going to go down here. I'm going to create another loop. So for I in range len dist. So what this is doing is this is like for each value in the array distance. So each one of these in this array, we're going to do an if. We're going to run this code. So then if dist I, so whatever number we're on, is less than or equal to 1, then, and I did, oh no, we are going to take success and add 1 to that. So what this is doing is for each value in distance, we are going to run this. So if this value is less than or equal to 1, if the distance away from 0 is less than or equal to 1, if it is in our circle, then we're going to add 1 to our successes. Boom. That's done. So now we got to go on. Got to get out of this loop, get out of this if statement, and then we're going to type pi is equal to, actually what we should do is we should go up here and we should actually create pi is equal to, pi is equal to np dot e mpty parentheses square bracket 0. So that's creating an empty array called pi. And then down here we can do pi is equal to np dot append. Oh, let me quickly go up here, fix this. This is really annoying. I always hate when it's, oh yeah, like right here. Just make your code neat. That's the lesson. Anyways, pi equals np dot append pi, comma, 4-point times, and this is basically our equation to find pi. We're going to find pi for each random number that we have in our array. We're going to do this. We're going to fill up our array, each random number in this loop. That's what we're going to do. So times np dot float 64. So this is making a float, which is a decimal number that's really big. The 64 means that it uses 64 bytes or bits, one of those two. So basically our float can be bigger than just like point whatever. It can be point whatever, 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 whatever. And then we're going to have that as success. CC. So that's our successes. That's going to turn that into a float, multiplying that by 4. Then we also got to divide that by np dot float 64 size. So that's dividing it by our size. Actually, we have to divide it by n. We have to divide it by what number of sides that we're on. Don't make that mistake, because I did earlier, and that caused a lot of pain. Anyway, we gotta go up here. We gotta do actual underscore pi. So this is gonna be all for our array. Not our array, our graph here. That gets closer and closer and closer to pi as it goes. So this is actual pi. This is this red line down here. So actual pi equals np dot empty. And then same thing, boom. And then we're basically going to do the same thing. Actual pi is equal to np dot append. Append. And then actual pi, comma, 3.1415926538462643388379502. That's actually a little bit much. Let's just go down to here. 3.14159. That's good enough. And then that's going to be what actual pi is, what this red line is going to be. So now we got to plot it out. We're going to want to go back here, and actually we're going to want to import. So import matplotlib as plt. Boom. So then here we have plt dot plot, and then we are going to have np.arange len pi, comma, pi. So what this is doing is this is plotting something which their x value, the length of their x value is equal to the number of values in pi. And then the y value is equal to whatever value of pi that is. And then we're going to copy this. And we're going to go down here. I'm going to paste that. It's going to be the same thing, except actual pi, comma, and then we're going to make this red, because we want to have this nice red line going through here. And then plt dot show. So if we run our code here, then we will have an error because we imported it wrong. So I think we have to from matplotlib, we have to import pyplot as form, not form. There you go. So yeah, don't do that. It worked before, I think, but you gotta do it this way. Boom. So now we should be able to run this, and there's a graph. So we only have 100 values. It isn't that exact. Let's just crank this up to 1,000. Take a look. This will have to wait. It will take quite a while to run, because this is a program. This isn't going to be completely accurate. We'd have to go on for forever, as pi is infinite, to actually get it correct. But, you know, we will see. And it's just running. Just let it run. Oh, there we go. So you can see we had really, really strange drop way down here. And then it smoothed out. And this plot basically can show you how this calculator smooths out as it goes along. So it was like crazy, crazy weird over here. And then it went out to be pretty much exactly pi. So now, like, what did we get? What was our actual pi? Well, we'll figure that out. So the last thing that we got to do is we got to print, and then 4 point times, in parentheses, or actually not in parentheses, np dot a dot float 64. So basically the same thing that we did up here. Success divided by np dot a dot float 64 size, and then we gotta also multiply that somewhere here, size by 100, as we multiplied it by 100 up here, so we gotta even that out down here by multiplying it by 100 as we are dividing right here. So then, if we run this and wait a little while, then eventually, as this thing does take quite a while, and there goes my computer running its fans off because it's got a lot of work to do. Yeah. Anything that we can make this thinner? No. And eventually, sometime, if this program wants to work or not. Oh, there you go. We have our plot, and we have our answer, 3.14228. Nice. So that is a Pi calculator and plotting program in Python. So hope you learned something, and thanks for watching.